Lesson 3.3 is titled Polynomial Identities. There are lots of examples in this lesson and lots of definitions. We'll get as far as we can in the video and continue on with our notes in class tomorrow. In this lesson, we'll use polynomial identities to multiply and factor. We'll also use Pascal's triangle and binomial theorem. So lots of review and lots of new things. Let's start off with an identity. An identity is just useful to help transform one side of an equation to another. Oh, and then I'm thinking as I write. All right, let's try that again. Helps transform one side of an equation to the other. Like when you add 5 to each side to solve for x, that would be using an identity. In this lesson, we'll use lots of identities that we've done before, and we'll use identities as a way to simplify foiling, and then we'll learn some new ones. The first one is multiplying the square of a sum, and that definition is actually over on the right-hand side. Since it's kind of expanded, I wanted to make sure there was enough room for you to see what it was. A plus b squared follows the template a squared plus 2ab plus b squared. So we'll try this model, and if you like it, great. If not, you can always FOIL and get the same result. I have no preference. But let's try this definition and we'll see what we think of it. If you know what A equals and you know what B equals, we're just going to plug it into this template. So our example on the right, we're going to multiply 3x plus 4y squared. So instead of FOIL, I know that A is going to equal 3x because that's what's written first, and B is 4y. So I'm going to substitute it into my definition for A and B. A is 3x, and we're going to square that. So 3x squared plus 2 times A times B, so that's just one big product right there, plus B squared, so that's 4y squared. And now we just simplify. 3x squared would be 9x squared. Square both parts. 2 times 3x times 4y, well 2 times 3 is 6, 6 times 4 is 24, times x times y. 4y quantity squared would be 16y squared. So that is the answer you get applying the square of a sum identity. And again, the trade-off is you could FOIL. Another definition that we've actually done before is the reverse of FOILing. It's factoring differences of squares. And again, that definition is on the right-hand side. Whenever you have a perfect square minus another perfect square, we split it into the square root of their sum and their difference. And we've done this before. So if we have 25x squared minus 36y squared, then A is actually 5x, and it's being squared in the equation. B would be 6y, because that's also being squared in that equation. Using the identity on the right, if we want to break that down, A plus B would be 5x plus 6y, A minus B, 5x minus 6y. And we've done that kind of before with smaller expressions like x squared minus 9 maybe. This is a way to do this with higher ordered functions. And now we have a couple of new models, the difference and sum of two perfect cubes. The formula is up above and down below. If you know something's being raised to the third power and you have subtraction and you're trying to factor it, the factor rule is a 2 parentheses set. You wouldn't actually use 3 parentheses. So it's not a minus b cubed. It wouldn't factor like that. So just make sure you're not trying to take the shortcut and get done faster. If you have a perfect cube minus another perfect cube, and you can tell what A and B equal, you'll have a little parenthesis and a big parenthesis. And we'll just follow that template. Over on the right, it says 8m cubed minus 27. So now we have to think about this a little bit. These are a little bit trickier. Instead of perfect squares, we need something that multiplies by itself 3 times to get our value. If our first term is 8m cubed, what number could we cube to get 8? That would be 2. What variable m would we raise to get to m to the third power? That would just be plain m. So if a equals 2m and you cube each part, you'd get 8m cubed. Let's try b. What number times itself 3 times would equal 27? That's 3. So b equals 3. Once you know a and b, we're just going to follow that little parenthesis, big parenthesis rule. 8m cubed minus 27 equals a little parenthesis and a big parenthesis. In the little parenthesis, it's just a minus b. We'll write it out as 2m minus 3. In the big parenthesis, it's a squared, so that'll be 2m squared. And then it's plus a times b, which is 2m times 3. And then it's plus b squared, which is going to be 3 squared. Oh, I barely got that to fit in there. All right, now we need to clean that up. We always simplify this. I know this seems like a big process. That 2m minus 3 is going to stay 2m minus 3. And then we have 2m squared. Square the 2, square the m, and that gives us 4m squared. Plus 2m times 3 is 6m. Plus again, 3 squared is 9. And the great thing about this expansion is that little parenthesis is good, but that big parenthesis will never factor further. So you're only going to have 2 parts, or 2 parentheses. You'll never have 3. And that's when you work with the difference. Now let's try the sum. Notice the formula is almost identical. You have a cubed plus b cubed this time. So now your little parenthesis stays a plus b. The big parenthesis is now a squared minus ab plus b squared. But it's the exact same process as up above. If you can tell what a is and what b is, we're in great shape. We have g cubed plus 64h cubed. If that first term is g cubed, then a would equal the variable g. And that doesn't need a quote. I don't know why I did that. I'm trying to make it fancy. A just equals g. In that second term, what number times itself, times itself, times itself 3 different times would equal 64? Well, I know 8 squared is 64, but that's only 2. We need 3. I think 4 would work. 4 times 4 is 16, times another 4 is 64. So if we take 4 times h and cube it, we would get 64h cubed. We know our a, we know our b. Therefore, g cubed plus 64h cubed will again equal a little parenthesis and a big parenthesis. I'm going to make this one even bigger. The first parenthesis is just going to be a plus b, or g plus 4h. In that second parenthesis, that's going to be the first term squared, or a squared, which is just g squared. But then notice the formula is minus. Then it's g times 4h, and then it's plus b squared, which is going to be 4h squared. And once again, let's simplify if possible. G plus 4h, not like terms. And then we have g squared, nothing happening with the coefficients, we'll keep it g squared. If I multiply those two terms together, I get minus 4gh. Then it's plus 4h squared would be 16h squared. And again, you get your little parenthesis and big parenthesis, and nothing will factor further. Let's have some fun with these 3 examples. Example 1 simply says to multiply 2x squared plus y cubed quantity squared. This follows our square of a sum definition. So this would be a plus b squared. And in this instance, a is pretty big all by itself. It's 2x squared. B is y cubed. And we have to plug it into that template. Or you could FOIL. Choice is yours. If we apply our definition, just to give it some practice, go back up to the top. The formula for sum or square of a sum is a squared plus 2ab plus b squared. And we have to plug in for a and b. We're just going to do substitution. A is 2x squared, so I'm going to take 2x squared and square it. Plus 2 times a times b. A is 2x squared again. And b is y cubed. Whoops, I wrote b. Didn't mean that. Y cubed. There we go. Plus b squared, which is going to be y cubed squared. Oh boy, this looks like fun. In our first term, we have 2x squared being squared. So that means we have to square the 2, and that will give us 4. But when you square a square, you multiply your exponents together, which also gives us 4. And that's our first term. In that second term, if I multiply the coefficients together, we also get 4. It won't be 4 every time, I promise. And then we have x squared times y cubed, and that just stays x squared, y cubed. Plus, and this last one, y cubed squared, you have when you have an exponent on the inside and a power on the outside, we multiply them like we did before. 3 times 2 would be y to the 6th. So if you FOILed, you should get that same amount. And that's using the square of a sum identity. Now the opposite of FOIL is factor. So take a look at these two examples. Notice we have 9m squared, or 9m to the 4th minus 25m squared. Not even the words that I'm saying correctly. Wow, 9m to the 4th minus 25n to the 6th. That's what I wanted to say. If we take a look at 9 and 25, those are perfect squares. We would try to use the difference of squares formula, a squared minus b squared. And that equals a plus b times a minus b. If I look at 9m to the 4th, what number could I square to get 9? Well, that's not too bad. That's 3. That's easy enough. But if we have m to the 4th, and I want to square something to get m to the 4th, that's going to be m squared. All of that is what a equals. B, well, square root of 25 is 5, so that's easy enough. But then n to the 6th. Do you see how this example is kind of tying into what we just did? If you have n to the 6th power, what number could you square to get to 6? That would be n cubed. Now that we know what a equals and what b equals, we're just going to plug it into our formula. 9m to the 4th minus 25n to the 6th. We'll have a little parenthesis and another little parenthesis. That would be 3m squared plus 5n cubed times 3m squared minus 5n cubed. That's pretty interesting. Let's try another one. M to the 8th minus 9n to the 10th. Oh boy. Well, I see 9, and I recognize that that's a perfect square. And another thing to help you recognize that it'll be perfect squares, not cubes, is that your numbers, your exponents are even. So anything that's even is going to be a perfect square. If we follow our a squared minus b squared template, what number could what exponent could we raise to get to the 8th power when we square it? That would be m to the 4th. And then for 9n to the 10th, that would be 3n to the 5th. Wow. Once you know your a and your b, you would have m to the 8th minus 9n to the 10th equals little parenthesis, a plus b would be m to the 4th plus 3n to the 5th, and then m to the 4th minus 3n to the 5th. Ooh, That's crazy factoring and foiling right there. And that'll be enough for today with 3.3, day 1.